Hi everyone. Today let's look at another LeetCode problem. Now we have problem 155 called find minimum in rotated sorted array. Suppose an array of length n sorted in ascending order. Array is rotated between 1 and n times. For example, the array 0, 1, 2, 4, 5, 6, 7 might become 4, 5, 6, 7, or 1, 2 if it was rotated 4 times. If it 0, 1, 2, 4, 5, 6, 7, if it was rotated 7 times. So every time it is rotated 4 times, 1, 2, 3, 4. Okay, so we shift it to the right, and then if there is any element that goes over the array size, it will move to the front of it at the same order. Okay, so notice that repeating an array A0, A1, A2 until an minus 1 one time result in the array an minus 1, A0, A1, A2 until an minus 2. Given the sorted rotated array nums of unique elements, return the minimum. Okay, so nums unique, and then rotate means that A0, A1, an minus 1. If we rotate it, we would have minus 1, A0, A1 till an minus 2. Yep, it's also good. Given the sorted rotated array nums of unique element, return the minimum element of this array. Okay, so we want to get the min of nums. You must write an algorithm that runs in O log n time. Okay, interesting problem. Let me read the question problem to see if we have any questions. So array length of n, we have an array nums. All of the elements are unique, and it is sorted in ascending order initially, but now it is rotated between 1 to n times. I think we don't need to care how much is rotated because it's not even given in our input. But what we need to do is we need to find the minimum element in the array. Okay. I think I understand the problem now. Let's look at the examples. For the first one, we have nums. Oh, 3, 4, 5, 1, 2. Now the minimum is of course 1. Second one, nums is 4, 5, 6, 7, 0, 1, 2. Output is 0. Now the third one, we have nums equals 11, 13, 15, 17. This will return 11. Okay, so I would like to clarify a few. Yeah, at the end, there's not much to clarify here. How about the size? I think just a basic assumption. Length of nums. So it's given here is between 1 to 5,000. Yep. I think I understand the problem now. Let me think of some possible approaches for this. So we need to do this in O of log n times, meaning that alright, I think it's pretty clear that we need to use binary search on this. But the problem is what kind of binary search that we need to apply to this, given that it is not sorted anymore at this point. But then if we split it into two different arrays, we could get a sorted array, two sorted array. Okay, let's see. So in the first problem, we have 3, 4, 5, 1, 2. If we try to check the left and the middle and if we take a pivot on the middle, we have 5. Then we see that 5 is greater than 3. But the 5 is also greater than 2. So this means that, okay, so what does it tell us? It tells us that the left hand side is sorted, but the right hand side is not sorted because the rightmost value is lesser than the pivot. Okay, so I think that is one observation. Let me just jot it down. Call it findings. First one, if mid is greater than right, then it means that half of left sorted, half right unsorted. Okay. How about the case where the first left is not sorted? So I think that's also possible. Let's see. Okay, I think in a sorted array, you would have a mid that is greater. So in sorted we have left is less than mid, and mid is less than right. So if we have left that is greater than the mid, then this means that another half right, so the half left is unsorted and the half right is sorted. Okay, so let's see what we do next in the first example. In this case, we are gonna have to look at the the right hand side, the half left, and the half right of the array so that we can find the minimum. So if we just look at the half right, we have 1 and 2, and this seems to be sorted, so we get the leftmost value, right? If we get the leftmost value, then we get the minimum value of the whole array. So I guess one thing that we can do is, if the left is less than mid less than right, then we can return the left, because when left is less than mid and the mid is less than right, it means the whole thing is sorted. So to get the minimum, we just return the leftmost value of the array. I think that makes sense. Okay, let's just try with the second example that we have here. So we have 4, 5, 6, 7, 0, 1, 2. The mid value is 7. So we see that. Okay, so let me write down one more thing here. And so we go here. So we go with whatever part of the array that is not sorted yet. Okay, so we have 7 in the mid here, and then at the end we have 2. So the right hand side is not sorted. Then we check the 0, 1, 2. We see that left is less than mid, mid is less than right, so we return 0. Okay, that makes sense. The third problem, we have 11, 13, 15, 17. And this is sorted, so we return 11. Okay. I think that sounds reasonable. So we try to use a binary search to find which half of the array is not sorted. Whichever half it is, we do a recursion on that to find until we find that there is already a sorted array, and then we just get once we get the sorted array, we pick the leftmost value of it. Does it sound reasonable to you? I am pretty good about this. May I proceed to programming? Alright, thank you. So what I'm gonna do here is I'm gonna use a recursion, and we are asked to implement this function find min. So find min of nums can do is using the mid. So mid is, let's do length of num divided by 2. Okay. Then I'm gonna check whether it is all sorted. So this means that, let's see. Okay, so let's do this. I'm gonna create two variables. Is left sorted equals nums of 0 less than nums of mid. Then is right sorted equals nums of mid. I guess I need to use less than or equal. Nums of -1. Okay. Then I'm gonna do if is left sorted and is right sorted. Return the first element. Otherwise, if not is left sorted, then I'm gonna do recursion on the right hand side. So we need to handle an edge case here. What if there is only two elements and what if there is only one element? If there is one element, then the mid is 0. In this case, we return the only element. That is correct thing to do. If there is only two elements, then the mid will be 0. In this case, the left is sorted, the right is, let's say the right is not sorted. So, okay, how about the left is not sorted? Okay, so let me just write down the edge case. So if there is, let me write down at the bottom here. I'm gonna use the next page. So edge cases. One is n is 1, then it return nums of 0. If there is 2, what it's gonna do? In this case, the mid will be 0. Oh no, actually the mid is 1. Then it will check. In this case, the right hand side is always sorted, but the left may not be sorted. If the left is not sorted, then we need to check the, and then this, we need to recurse the nums of 0 to mid -1, and then this boils down to the first edge case where the n is 1. Okay. How about it is sorted? Then we don't need to worry about that. Then the third one, if there is 3 elements, the mid would be 3 divided by 2. That would be 1. So the mid value. And then in this case, it's either recurse left or recurse right. So I think there is no issue here. Let's see. So at the left is not sorted. How is the left not sorted? Okay, how about the minimum is at position 1? Then let's see how we should handle this. Sorry, I will struggle with all of these such edge cases. I'm gonna take some time here. Let's see. I can't just use the left part if it is not sorted. Here is one. Okay, how about with the n is 2, then we just return the minimum. Is that the right thing to do there? Okay, I think to simplify, if n is just 2 elements, then we return the minimum. Or even if it is 3, then we just return the minimum. Yeah, I think that should be fine, right? Yeah, I think that should work. So find nums. If length of nums is 3, then I'm gonna return the minimum of nums. Otherwise, I'm gonna do all this recursion again. If left is not sorted, I'm gonna find min on the left hand side, including the mid, so as to simplify all our edge cases. So nums of 0 to mid plus 1. And if, so in here I can call just else. There is no way that all left and right is not sorted, right? Because that will be a decreasing order. I think that's impossible. Yeah. Okay, so I can just use an else here. So find min. So in this case, the right hand side is not sorted. And what we can do, can check the mid. When we don't need the mid plus 1 until the end. Okay. Yeah. So let's see, do I even need to handle the edge case? If length is 3, so if length is 3, the mid would be the middle one. If the left hand side is not sorted, then I go to that array, and then I will check the minimum. At that point, the left would be that. Okay, so I guess the edge case is when the length is 2, I just return the minimum. Is that correct? Let's see. If the length is 2, okay, let's go through some example. Okay, I think this should work. Let me quickly walk through the code. Let's see how it's tested. Okay, how about we go through some example of edge cases. So here, let's see, we have just 1, and then 1. Mid is also, see, wait a minute. Nonce is 1. The mid we pointed here, and so it's all sorted. Then we return 1. How about there are 2 elements, 0 and 1. The mid will point at 0. And here it's all sorted, so it will return 0. Third cases, if it is 2 elements and it is not sorted, mid will point at 1, and we see that the right hand side is not sorted, so this will move on to 0, and then yeah, we still got the answer to it, which is 0. Then when there is 3 elements, 0, 1, 2, mid will point at 0. Mid will point at 1. It's all sorted, return 0. How about it is shifted by 1 time to 0, 1. In this case, the left hand side is not sorted, so we got 2, 0, and then at the end it will return 0. How about if it is sorted 2 times, 1 to 0, right hand side is not sorted, so we explore just the right hand side. Yep, I think this should work. So I'm thinking that we don't need to handle the edge case because all of our condition here will handle it, and the first return is sufficient. Okay. Now let us put it into LeetCode platform. Hopefully I got it right. So min is length of nonce divided by 2. I just say left is good. So left is nums of 0 less than nums of mid. Right is, okay, don't forget the equal sign there. Right is nums of mid is less than or equal to nums of the last element. So if left and right become nums of 0 and is not left, we can find min of the nums 0 to, let's see, mid plus 1. Else we will explore the right hand side. Mid plus 1 towards the end. Okay. Try to test it. How do I let's see. Find min. Okay. So the find min is the cell function of, because I'm gonna use recursion search. Need to pass in the cell, run it, find min. Okay, there's a typo here. Yeah, we got it right. Let me can we add the cases? Say 0. Run it. Okay. Try to submit it. Hopefully it's correct. Wrong answer. Recursion error, maximum recursion depth exceeded in comparison. What does that mean? Okay, so I made a mistake here in the answer. Because interesting. Yeah, so because 2 divided by 2 becomes 1. So but I take a minus 1 here. So if there is 2 elements, I want the mid. Hold on. Okay. So how about just for simplicity, length of nums is 2, length of nums is less than 3, we just return min of nums. How about this? Yep, we got it right. Okay, so on the solutions that are more efficient, I think let's see. Okay, thanks. Doing roughly the same thing, but this instead of using recursion, this is an iterative solutions. This is not an all or n solutions. This is iterative. Yeah, I think I'm good at this. Good with this. It's just some of these are not recursion. Okay, cool. Think that's it for this problem. Thank you everyone.